to go? Cool. All right, let's get started. I think we got the tech issues figured out. Sorry about that. Thank you for coming. This is OAuth and OpenID Connect in plain English. I'm Nate, and I'll be your tour guide through the fascinating world of authorization protocols for the next hour or so. Quick show of hands, who here has worked with OAuth or OpenID Connect in the past, or at least heard of it maybe? A couple folks? All right, cool. I don't know about you, but when I started trying to learn this stuff, I found it extremely confusing because there's like a ton of jargon and a ton of it's like technical terminology that is like really hard to grasp if you haven't done it before. And at least my experience was, if you Google it, what you end up finding is either one, you find the spec, which is really light reading, or you find some guy's blog post or like half-baked Stack Overflow answer that explains like exactly what it is if you already understand it, which is not very helpful if you're trying to learn it. So my goal with this talk is to kind of demystify a subject that tends to be a little complicated, tends to be a little confusing, and just make it a lot easier to understand. So what we're going to do is I'm going to talk a little bit about a little bit of history, and then I'm going to talk about the OAuth protocol, OAuth 2.0, and then I'm going to talk about OpenID Connect, and then if you all have any questions, we can go from there. So I want to start at a really basic level and talk about kind of how a lot of websites used to do authentication and how authentication is still done on a lot of sites. And that's something called just like forms authentication. It has some other names. But this is just the idea that you are entering your password on a site, and in the background, they're just making a lookup to their database and checking your password against their database, looking up your user info, seeing if your password matches, and then if so, saying, yep, you're logged in. This is kind of like the basic form of authentication, and this is how it's been done for a long time, how it's still done in many cases. Hopefully, if you're building something like this, hopefully you're properly hashing passwords and all that stuff for security reasons, but it's not always done that way. Typically in a system like this, after the username and password is checked against the database, then the client application or the website will drop a cookie into the browser that identifies that the user's been logged in. Usually it's like some type of session ID or a session token. And that identifies that the user's been logged in and kind of is sent back and forth from the browser to the server on subsequent requests, so you don't have to keep logging in. Now this is, like I said, how it's been done for a while. There are a couple of downsides with this approach. One downside is that if you're building this yourself, if you are building your website or game or app or whatever, and also building the authentication system behind it, then you're kind of on the hook for all the security that goes into an authentication system, which can be like a lot. And the security industry tends to change pretty rapidly sometimes. So like if you built this a little while ago, and back then maybe like MD5 was the way to hash passwords, so you did that, and then a couple of years later, like that white paper came out that said MD5 is horribly broken and you should never use it, then you're going to have to change to like hashing passwords with SHA-1. And then just like last year, SHA-1 was cracked, so now you have to use like SHA-256. So there's a lot of like security stuff you have to keep up with if you're doing this yourself in your app. And that's kind of like a lot of maintenance work. So also, there's also kind of the effect of like you might end up spending a lot of time working on authentication code when what you really want to do is like you just want to build your application or your game or your app or whatever. Instead, you end up having to kind of be a security expert to make sure that this login and registration stuff is all working properly. And like it or not, no one ever downloaded paid for an app or bought a program because the login system was like really nice. That just doesn't happen. That's not something that you typically like make money on. It's just kind of like what you have to do. So OAuth 2.0 and OpenID Connect are kind of one of the best practices or one of the standards that the industry is kind of rallying around to solve some of these problems. And I'll explain how they solve these problems in a bit, but what I want to do is explain how these protocols work, because that part is usually pretty confusing to people. As I mentioned before, this topic ends up being really confusing online. There's a lot of like incomplete information. There's a lot of misinformation online. There's a lot of people who don't know what they're talking about, giving strong opinions. So this is a confusing topic. What I want to do, what I found helpful when I was trying to understand this, is kind of going all the way back to the beginning of what problem these protocols were trying to solve, because that helped me understand why they act the way they do and why some of the things, the jargon is what it is. So we're going to look at something called the delegated authorization problem. Has anyone heard of the delegated authorization problem? Probably not. It kind of sounds like the episode, like the title of a Big Bang Theory episode, but it's a problem that was prevalent on the internet like maybe 5 or 6 years ago. And it's a pattern that we're super used to today, but 5 or 6 years ago it didn't exist. The problem that we're talking about here is this idea that you have some data in maybe one system, and you want to let another system access a little bit of that data, but not all of it. So an example that you'd see today of this is like when you use your Facebook account to log into some other website, like, I don't know, the New York Times or whatever, to leave a comment on that site with your face and your like Facebook name. You have to go through the whole little flow where you click the blue button to log into Facebook, and then it says, are you sure you want to let the New York Times access your Facebook public profile? This is going to give them your email address, but it's not going to let them post to Facebook on your behalf or whatever it says. And you decide if you're okay with that, and you click like, I accept this, or you click no. And through that kind of flow, then that other site gets access to a little bit of your Facebook info, maybe your friends list or your email or your name or your profile picture or whatever. So that whole pattern that we're really used to today on the internet didn't exist a couple years ago. Now it's kind of just part of like the internet lexicon, but it didn't exist, and that was actually a big problem. So way back in the day, there were other people trying to solve this problem or coming up against this problem. For example, this is a screenshot from the very early days of Yelp. This is before Yelp was a big company. They were a tiny little startup, and when you registered for Yelp, at the end of the registration process, they said, hey, thanks for registering for Yelp. If you want to send an email to all your friends, because your friends love getting spam from you, send an email to all your friends with a code to invite them to Yelp. And that's like not super uncommon. Like a lot of sites will want to get you to invite your friends to sign up or whatever. But at the time, they didn't have a way for you to like authorize them to get access to your friends list to email your friends. What they did was they said, okay, give us your Gmail email address, and then give us your Gmail password, and we'll log into your Gmail account for you, find all your friends, email them all, and then log out and throw away your password, and we promise we're not going to do anything bad with your password. And at that point, like at the time, these were like kind of nobodies. Like nobody knew who Yelp was, so like you're just kind of taking it on the honor system that they're really going to throw away your password and not store it or leak it or something like that. What's that?
Give your password for some reviews of food.
Yeah, exactly. So in case it's not clear, like this is a really bad idea. You should not do this. And if anybody is asking for your Gmail password like this, you should not give it to them. But I'm not trying to pick on Yelp too much. At the time, there wasn't a good way to solve this problem. There's only a bad way to solve this problem. But today, we would be able to solve this problem with the protocol called OAuth. And that's kind of what you see all over the internet today, although that's probably didn't know that's what you were seeing, but that is what you use when you're trying to kind of do this, like allow Facebook to use my stuff here or allow Google to use my stuff here. So I want to walk through exactly how that works. So let's say that using the same example, let's say that you were on Yelp.com and for some reason you decided you did want Yelp to be able to email all your friends to spam them and invite them to Yelp. But you don't want to give Yelp your Gmail password because that's just a really bad idea. So how that might work today is you would click on maybe like a connect with Google button or a login with Google button on Yelp. What's going to happen is that your browser, your web browser, is actually going to get redirected over to a Google domain. So you're no longer on Yelp, you're on accounts.google.com. And then you're asked for your email and password to log in. Now, that you can feel a little bit better about that because at least you're giving your password to a Google domain. You're actually giving it to a Google system and not to Yelp, so that's better. And then what you're probably going to get is some type of like screen that says, hey, what you're doing is you're trying to allow Yelp to access maybe your public profile and your contact list. Are you okay with that? And assuming you click yes, then you're going to get, the browser is going to get redirected back to Yelp to a special location on the Yelp website called a callback. And then Yelp is going to do some stuff behind the scenes with the kind of proof that you clicked yes to that screen on Google. And then it's able to go talk to Google on your behalf and say, hey, you know how that user just said I'm allowed to access this information, their email address or whatever? Can I have that information? And Google's going to say, because the user said yes, you're allowed to have that. So much better, because you never actually give your password to this other website. You're just kind of letting those websites talk to each other and giving your consent to allow that to happen. So this whole flow is the basis of the OAuth protocol, or is what the OAuth protocol describes. One of the things that's so difficult to understand about the protocol, if you've never read about it before, or you're trying to understand it, is that all of these steps have like really jargony technical names. And that was at least something that I found pretty confusing. So you're gonna get really tired of seeing this flow diagram, because I'm gonna go through it like 5 times, but I'm gonna kind of slowly add in some of the jargon, some of the tech terms, so you can kind of understand what all these pieces are. All right, so let's add some terminology. In the OAuth spec, in OAuth land, the resource owner is the user, basically. So you or me, whoever actually owns the data that the application needs. So in this contrived example, I might be the user who wants to allow my contact list to be shared with Yelp. So I'm the resource owner. The client is, in this case, Yelp, the application that wants to get my data, but it has to go through another system to get it. The authorization server is that other system that I can log into, in this case, Google, accounts.google.com, that I can actually log into, give my password to, and then that system is able to ask me whether I want to share this information. The resource server is another system that actually holds that information. So there's one system that I can authorize with, or say I'm logging in, typing my password, clicking yes. There's another system which maybe holds my information. So in this case, maybe the Google Contacts API actually has the data that Yelp is trying to get to, but I log in to the accounts.google.com system. One of the other terms that you'll come across is this idea of a redirect URI. So that's just a fancy way of saying the path or the address where the authorization server is going to redirect back to the client after I click yes, after I say yes to that screen. And then finally, this whole dance, this kind of whole flow, the whole point of it is to get what's called an access token. An access token is the kind of the stamp of approval, or the proof that I, as the user, said, yes, this client application is allowed to access this data. And this access token is a thing that the client application can use when it goes and talks to the resource server and says, hey, I know that normally I'm not allowed to have this information, but I have this access token that says I'm allowed to have this information. I skipped one, actually, sorry. The authorization grant, I'll show you where that fits in. That's basically the proof that I said yes to that screen. But let me show you this flow again, and I'll put some of these terms in as labels, and you can kind of see what all the pieces are. So again, we're starting here at the client, which in our case is, in this example, is yelp.com. I'm the resource owner. I'm the user who's sitting in front of the keyboard. My browser gets redirected after I click that button, gets redirected over to the authorization server. And in that redirect, there's some data that's exchanged. Some data is sent over. It's just like in the query string to the authorization server. One of the bits of data that's sent over is the redirect URI. So right at the beginning of the flow, the client is saying, hey, authorization server, if you're able to get the user to agree to all this, here's where I want you to come back to at the end. And then the authorization server does its thing. You can log in, you can say yes, and then the browser is redirected back to the redirect URI that the client had asked for at the beginning. And then along with that redirect, going back from the authorization server to the client, the authorization server passes along something called an authorization grant, which is just a little string or a little set of characters that is a proof that I clicked yes to this screen or yes to this button, gave access. That authorization grant can come in a number of different forms. In this case, we're talking about something called an authorization code. What the client application does with that code is it can't do a whole lot. That code can't be used to go talk to the resource server or talk to an API and get information. The only thing that the code can be used for is doing an additional exchange with the authorization server, basically going back to the authorization server and saying, hey, I just got this code because the user clicked yes. Can you please give me for this code an access token? And like I said, the access token is kind of what the client is after this whole time. With the access token, the client can finally go talk to the resource server and say, hey, I've got this access token, please give me this data. I'll talk a little bit more about why that extra step is required and why the access token isn't just sent back immediately from the authorization server. But first, we need to add a couple more terms. In OAuth, question?
I was just going to say, the authorization code, is that stored in the browser like a cookie, or is that all on the server side?
Very good question. Neither, actually. It's not server side. It is in the browser. It's not actually stored in the browser, though. It's just transmitted in the browser.
So if you've authenticated with Yelp and then you go to the redirect URI again, what would happen?
So, like, are you saying, like, if I'm here, but then I click back in my browser and go back a step, or?
You open a new URL after seeing what the URI was. Is there, like, logic in there that says, hey, if he's already been authenticated, then do this?
Oh. That,
is it like a one-time thing, or is it like?
The authorization code is like a one-time code. But if you went through this whole flow again, you could get a new one. Okay. And depending on how the authorization server is implemented, sometimes the authorization server will remember that you already logged in, and it won't like ask you to log in again. It'll just send a new code over. But basically, yeah. So the code is transmitted in the browser. It's usually in the query string of the redirect here. And it's kind of like a temporary code. It's not ever saved. It's not stored anywhere. It's just used by the client application to go do the exchange. And it usually is very short-lived. It's like lasts for maybe 30 seconds or 60 seconds or something. It doesn't last very long because the only thing it's good for is doing that exchange. And once you use it to do that exchange, you don't need it anymore. Also, you don't want the reason that is fairly short-lived is you don't want someone to like steal it. Ideally, you don't want someone else to go redeem that code and get an access token that they can use. You want to redeem it immediately and use it yourself.
Okay.
Good question. Feel free to shout out any other questions if you have. So let's add a little bit more terminology. In OAuth, there's this idea of scope. So a scope is basically a specific type of permission that you're asking for. So if you think about, like, say, we'll keep going on this example of me Yelp connecting to Google to get some of my Google information. Instead of it being kind of like all or nothing, like Yelp either has access to everything in Google about me, my Google Drive, my Google Photos, my Hangouts, my Google Plus, if anybody uses that anymore, like all that stuff. Instead of them having either all of that or none of that, scopes allow Yelp to say, I want to have access to your email address and your contact list, and that's it. Or I want to have read-only access to your files, but I'm not going to like delete your files or something like that. So scopes are basically a way to have a granular way of saying, I want this permission and this permission, but I don't care about anything else. And then kind of the flip side of that, or the corollary of that, is consent. So consent is when the user is presented with a screen that says, hey, this application, Yelp or whatever, is asking for permission to have this stuff. And it usually is kind of like enumerated for you so you can see what they're asking for. In the case of Facebook, they make it like really explicit whether this app is asking for permission to post on your behalf or not, or whether the app is asking for permission to like a page on your behalf or not, or if it's just like wants your contact list. So it's really important to let the user know exactly what scopes are being requested, and that's what that consent screen is for. So if we look at this flow again, same flow. One of the other things that's sent along in the initial request is a single scope or a list of scopes that the client application is asking for. And then when we get to that consent screen, that's what's used to kind of populate whatever message is shown to the user. So the important thing here is that the client application can ask for specifically the permission that they want. And then when we get all the way through this dance and the client application gets back an access token and then goes and uses that access token to go talk to some other API, like the Google Contacts API or the Facebook API or something, the access token itself is scoped to whatever the scopes were that were requested at the beginning. So in other words, I couldn't get an access token that scoped for profile and contacts and then go try to delete your files with it. It just wouldn't work because it wasn't requested with that permission. Now, if Yelp wanted to do something else that it didn't ask for originally. We could go back through this flow and ask for more scopes, and the user would have to kind of like additionally consent to more stuff, and then we get a new access token that has more scope, more permission. But basically the access token is limited by what scopes were requested at the beginning. Is that making sense? Awesome. All right, so you might be wondering that why some of these lines are solid and some of them are dashed. And the reason for that is because these are different types of requests, or rather requests going over a different channel. So we need to add a little bit more terminology, but we're almost done with the jargon. So in OAuth, or rather I guess more like in just like security and networking, there's this idea of a back channel and an idea of a front channel. A back channel is a very like highly secure communications channel. So on the web, we use like TLS, HTTPS to make sure that our connections are encrypted, all that good stuff. That's great. But if you think about a browser may be using HTTPS to communicate with a site, which means that all the data back and forth between the browser and the server is totally encrypted and can't be like spoofed or sniffed by anybody. But browsers themselves are a little bit of a security hole in that kind of stack. Because if you think about like somebody could have a weird toolbar installed in their browser that's actually like malware that's watching what the URLs that you're going to is, or just simply someone could be looking over your shoulder and see that code in your browser, the authorization code could be seen by somebody as it kind of goes across your query string in the URL. So for those reasons, a browser is considered a slightly insecure channel. It's like pretty secure, but not like rock solid secure. And that it's something called a front channel. Now, a back channel is like the back end server code of this application connecting directly to Google or directly to some API, in which case that's never going over your browser. That's all like encrypted connections, and your browser basically is never in the loop for that. So back channel, your browser's not involved. Front channel, your browser's involved. And you'll see in these flows that some of these flows split things up a little bit differently as to whether your browser is involved or not. So this flow that we've been talking about, which is called the authorization code flow, because at the end you get an authorization code, is primarily happens on the front channel. All of these redirects here where your browser is being redirected from the client to the authorization server, and then from the authorization server back to the client to the callback. Those are all happening on the front channel because it's your browser being actually page redirected with some query string stuff or maybe a form post or whatever, but that's all happening in the browser. And those are all things that are happening on the front channel. And that's okay as long as we aren't sending anything that's really sensitive over that front channel. So if we look at the stuff that's being sent back and forth here, we have the redirect URI, but that's fine if that's like public information. That doesn't really need to be protected. The scopes, that's fine on a front channel. Doesn't have to be like highly secure. Even the authorization code, although we wouldn't want someone to steal it, it's okay that it's on a front channel because the next step happens only on a back channel. So when the client application gets that authorization code back, and it has to do the exchange and say, hey, I just got this code, please give me an access token, that exchange entirely happens on the back channel and is never happens in the browser. Another way to say that is that the access token is never stored in the browser or even seen by the browser, which means that this exchange is very secure and it prevents or mitigates the risk of someone stealing that access code, or sorry, stealing that authorization code and then trying to kind of beat you to the exchange and go exchange it, because that happens on a back channel and it requires some additional security stuff. I'll show you more about that, what that looks like in a second, but it's just important to point out that that happens on a back channel, and then the communication with the resource server also happens on a back channel where the access token is being used to communicate with some API. That also happens entirely on the back channel, so not liable to be intercepted by something like sniffing on your browser or something like that. Okay, so we've been primarily talking about this authorization code flow. I'll show you some other examples of variations of this a little bit later, but instead of showing you these diagrams, I'll show you kind of the guts of what this looks like. So when you actually click on one of those login with Google buttons or login with Facebook buttons or whatever, what is happening is that your browser is actually getting redirected to something that looks kind of like this. So this is a long URL, but it starts with some particular route on the authorization server that is called the authorized route. And to know what it is, you just have to like look at Google's documentation to understand what route you're supposed to use. But then a lot of information is sent along with this initial request. So I already talked about the redirect URI. I already talked about the scope. But there's a couple other things I haven't mentioned yet here. One is what's something called a client ID, which is basically just an ID that represents or refers to this particular client. So it identifies that this is Yelp as opposed to somebody else. And then something called a response type, which is how the client asks for a particular authorization grant at the end of the flow. So far we've really just been talking about an authorization code. That's how you would get an authorization code, by just asking for response type code. And then finally, typically something called a state is sent along as well, and that's just random or any string of characters that is sent along with the request and then just simply sent back to the client at the end, which doesn't sound all that useful, but sometimes it's used to do like an additional security check. Okay, so all of this is happening on the front channel because this is a browser redirect, and this is a data that's being passed in the query string. But that's okay, because all of these things here are not particularly secret. If somebody knew the client ID, that's okay. If somebody knew the redirect URI, that's fine, not a big deal. Let me pause the slideshow here for a sec, and I'll see if the Wi-Fi is still working, and I can show you kind of a little demo of what this actually looks like in the real world. So if you're trying to integrate with Google, for example, what you're going to do is you are going to go to the Google Developer Console, and you're going to do something called create an application. That is the same thing as basically creating an OAuth client. They just call it creating an application, but you're creating an OAuth client. And when you do that, you're going to get assigned a long client ID and then a client secret as well. So that client ID is what I just talked about, that's sent along with that initial request. And the client secret is kind of like a password that's going to be used later. Unfortunately, I have to delete this now that you've seen my client secret. But what this looks like is, and also when you set this up, you also have to specify what, if any, what redirect URI or URIs are going to be used later. So the redirect URI, it actually has to be registered in advance with the authorization server as like an additional security measure. But let me show you what this looks like if you use it in like a real request. So in order to like make it a little bit easier to see how this works, and also to help me while I'm debugging this stuff, because it can be kind of hard to get it working the first time, I built a little tool called OAuth Debugger. So if you're trying to get one of these flows working and it's not working, it can be really tricky to figure out. So you can use this tool if you want to make it a little bit easier to see what's going on. What this tool does is it asks you to give it the authorized URI and the redirect URI and the client ID and the scopes that you want. Let's say it's profile. And any other information about the request that you need to specify the response type and the response mode and a bunch of different stuff, and then it generates that URI that you need to redirect to. And then it also lets you just try it out. So if I click send request here, I should be redirected over to Google. So this is exactly what it would look like if you were doing this in your own application. I'm already logged into Google, so it's not asking me to enter my password again, but Google has like this account picker thing that they do. So if I pick my account and authorize, I get redirected back to this redirect URI, which I set to be this application, and I get a code. So this is what the authorization code looks like. It's just a bunch of gobbledygook. And then, of course, the next step that this application would need to do if it was a real application is exactly exchange it for an access token. That exchange happens on the back channel, not in the browser, so this debugger can't do it, but I can show you what it looks like. Yeah, it's a post request. So, all the way back at the beginning. Darn. I'm going to fast forward here. Got all that? Okay, so when the application redirects, or when the authorization server redirects back to the client, it's going to redirect back in one of two states. What you just saw was a successful state where everything worked and it was all good, which means we got a code back. If something went wrong and the user maybe didn't consent or didn't log in correctly, or something was wrong in like the setup and you screwed up the client ID or something, you'll come back with like an error condition with specific error message that you can kind of look at. But assuming everything went well, you'll come back with a code, and then the next step is that authorization code exchange. So that's a post request to somewhere on the authorization server to something called the token route. This is what Google's token route looks like, but for Facebook it's a little bit different. And that post request has a body that it has to contain a couple of different parameters. You have to send along the code, of course. You also have to send the client ID, which we already sent before, but just send it again for good measure. We also have to send that client secret that I was talking about, which is kind of like a password that goes along with the client. And that value is like super sensitive. So we wouldn't want anyone to ever steal that or leak it for some reason, because if someone else had that client secret, they would be able to do this exchange instead of us. And that would be really bad because they might end up with an access token, and we don't want someone else to end up with an access token. So for that reason, this happens on the back channel. We don't want that client secret ever exposed to the browser. Now, assuming that all goes well and the access code, or the authorization code is still good and all that stuff, what's going to come back from the authorization server is a little JSON document that includes an access token and then some other information about the token, specifically when the token expires. So this is what an access token might look like, and then this is telling us that it expires in like 3,900 seconds, which is, I guess, like an hour and some change. So the client now has kind of gone through this whole dance to finally get this access token, and then the client can finally do something with it. Something would look like this. So at this point, the client can then go talk to, get, or post, or put to some other API, whatever API they were trying to talk to in the first place, and then along with that request, they would attach that token in the HTTP authorization header as what's called a bearer token. So it would be authorization, bearer, and then the access token. And so basically what's happening there is that the application is sending along a request to some API, including the token. And then that API, it's their job to kind of validate and say, okay, you're sending me this token, but I'm not going to accept just any token. It has to be still valid. It can't be expired. It has to have the scope for what you're actually trying to do. So if this is the Google Drive API, it can't be, and I'm scoped to talk to like the profile, that's not going to fly. Yeah.
So the idea is the token comes from Google, and then the client, like Yelp, checks the token, and then Google validates that? Or when you say validates it, who's validating it and how are they validating it?
Good questions. In this case, so what's happening here is that the whatever API that I'm talking to, it's the API's responsibility to validate the token. So in this case, it would be Google again, but maybe a different Google system, not necessarily the authorization server. The authorization server has the ability to like make new tokens, but other parts of the API are what consume them and validate them. And then specifically what that validation looks like is checking to make sure it's not expired, checking to make sure it has the right scope for whatever I'm trying to do. And then a couple other checks that I'll be able to talk about a little bit later. So sometimes that API just validates by simply talking to the authorization server itself and being like, hey, authorization server, somebody's sending me this token, is it still good? And the authorization server can say like, yep, looks good, or nope, it's expired. But I'll talk a little bit more about validation later. Let's just say for now that if the token passes all the validation checks and it's good, then that API is going to say, okay, application or client, you can have this data that you're asking for, you can perform this action that you're trying to do. And then the next time the client sends a request with that token, the whole thing has to happen again. The API has to validate it, make sure it's still good, say, okay, you're still allowed to do this thing. Or maybe, nope, you're not allowed to do it anymore. So I talked a little bit, actually this whole time we've been talking about the authorization code as being the thing that comes back from the authorization server. There's actually a couple other variations of this flow where maybe what you get back isn't an authorization code, it might be something else. And a lot of this has to do with whether or not you're using a back channel, a front channel, or both, or neither. It kind of gets a little confusing. But the most common type of flow other than the authorization code flow, which we've been looking at, is what's called the implicit flow, which is where there is no back channel. And instead of getting a code that you have to exchange and then get an access token for, you just get the access token right away from the authorization server. So let me show you kind of what that looks like. It's very similar. We're still redirecting over to the authorization server. We're requesting consent. We get redirected back. But instead of that redirect happening with a code that then we have to exchange on a back channel, in this case, there is no back channel. So we just get the access token right away. And then we just go ahead and use it. Based on what I was saying before, this is a slightly less secure flow because technically exchanging that access token kind of like over the browser, over the front channel, means that it could be stolen theoretically. So you might be thinking like, why would you do this? Well, sometimes some applications don't have a back channel. So if you're talking about like pure JavaScript single page apps, so like React, Angular, running entirely in the browser with no backend server, only hitting like a backend API but not actually being like rendered by a backend server, there's actually no back channel available. There's no backend code that's running somewhere before the page loads to run some code and handle that exchange and do a back channel request. So in that case, since there is no back channel available, this is like the next best thing. You can do this whole flow on the front channel, and that's called the implicit flow. All right, everybody good so far? We're halfway through, we can take a breath. I'm gonna take a short drink of 7-Up. Any questions so far? Yeah.
So the access token, so I know that the permissions, sometimes when you try to say authenticate with Facebook, it will then say list of the permissions you give, and then like one of them will kind of be like disabled. Usually I think like your name and your email, like you have to give them that.
Yep.
Then the other ones you can check or uncheck.
Yeah.
And then usually as a user you're like, well, I'm gonna uncheck them.
Right.
Give them my stuff.
Right.
I don't want to spam my friends. And then it will be like failed. And then you have to like clear the cache or your cookies and go through it again. What are your thoughts on that? Or like, why is it that way?
Yeah. So that is something that that whole kind of like letting the user customize their consent is something that's not in like the core spec. It's not part of OAuth.
So it's a Facebook thing.
But it's a Facebook thing. They kind of like added their own extension on. And I think it actually makes a lot of sense. It's pretty cool. And if I remember right, don't quote me on this, but I think it's actually an official like extension standard now. So it's like there's another spec that just talks about letting the user do that on top of OAuth. But specifically to what you're talking about, what they're doing is basically the client application is coming in with maybe a really long list of scopes, right? And then they're using that to show the user the consent screen. But what Facebook is additionally letting the user do is basically like check or uncheck those scopes. So what you're doing when you're unchecking those boxes and saying, no, I'm not going to give you all this stuff, you're denying a bunch of scopes basically. Yeah. So then what happens when you maybe say uncheck them and then click OK, you're agreeing to the OAuth flow, like you're succeeding the OAuth flow, but then the client application is getting an access token that doesn't have all the scopes that they wanted. And sometimes that's okay. It just depends on what the client application needs to do. So if like what they need to do depends on one of the scopes that you uncheck, then yeah, they're going to fail.
So do you think one possible improvement might be adding to that screen like required? Because the problem with that then is they're going to want to say required on all of them.
Right. Yeah. Exactly. If you gave them the option to like gray all of them out and not let you uncheck them, of course they would just do that. Yeah. Yeah. I don't know how to improve that. I think as a user, I like the fact that Facebook lets me be selective, right?
I just hate when it fails and then I have to jump through hoops to just get it.
Right. Right. Yeah, that can get a little messy, especially if the client application's implementation is not super great. Like, so if they don't really handle the edge case of you succeeding the flow, but not with as many scopes as they wanted, they might like not handle it very gracefully. So the first thing that the client should check is just like a sanity check to make sure I got the scopes I wanted, right? Or can I do the things I need? And if not, maybe let the user know like, hey, thanks for clicking yes, but actually we need you to click yes on this other stuff. And technically, let's say that you, as the client application, you get through the flow and then you don't have all the scopes you want. Or maybe just later down the road, maybe you like need some extra scopes that you didn't ask for originally. That's okay. All you have to do is go back through the flow. You basically just start the redirect again at the top, but add those new scopes into your list. And then what the authorization server should do is it doesn't have to ask the user again for the stuff the user already said yes to. It's just going to ask for the new stuff. Right. So it's like, okay, you've already authorized GitHub, but now would you mind authorizing GitHub and like access to your repositories or whatever? And then that's called, there's a name for that, it's like step up consent or something like that, where you already have this much, but they want to get a little bit more. So that's a thing that I think most authorization servers should support, but they don't always handle it super well. Part of the problem with the OAuth spec, if I was going to go off into like opinion land a little bit, part of the problem with the OAuth spec is that it describes all this stuff, and that's very useful, but it's also like very fuzzy in certain areas. A lot of the spec is like kind of wishy-washy, and it leaves it like, well, this is just up to the implementation of the authorization server. So like maybe. The problem with that, that's like nice on the one hand because the spec isn't like super like strict, but on the other hand, it's really bad because then you get all these like slightly different but mostly the same implementations, right? So Google OAuth is just like a slightly different flavor than how Facebook does it, which is a little bit different than how LinkedIn does it. And that can actually be really frustrating if you're trying to build a system that will talk to all of them, right? Because there's like little tiny variations. It's actually a perfect segue into what I'm going to talk about next. Any other questions, though, before we move on to OpenID Connect? Yes?
Yeah, you may have answered this already, but apps that kind of continually pull information from, let's say, Facebook, is that built in? Is that just based on the expiration of the token?
That's actually a good question.
If I update something on my Facebook, it's going to automatically reflect on Tinder because Tinder's pulling information from Facebook.
Yes. So as long as your access token is still valid, you can still get whatever information you are authorized to get.
So is it going to eventually ask me to re-allow all of that?
That's the trick. So not necessarily. So what happens when your access token was good for a long time and then it expires? There's a couple things that could happen. You could ask the users to log in again, but you don't necessarily have to. Let's say that you went through this flow originally and the user logged in and clicked consent and all that stuff, and then your access token expires. In most cases, you can send the user back through the flow, in other words, redirect back to the authorization server, and most of the time, if the user is still logged in to the authorization server, like you're still logged into Facebook, you'll actually get redirected back immediately, kind of like silently. So it's like a real quick like boop boop, and you come back, and then you get a fresh access token, or Tinder or whatever the client is gets a fresh access token. You'll see this occasionally on the web and also on mobile, where like you click log in and then it's just like pauses for a sec, and then it like flips really fast, and then you're logged in. That's what's happening. The access token was dead. We went over to the authorization server, and then the authorization server is like, well, this person's already logged in and they already consented, so back, here you go.
Gotcha. I thought it was the authorization code that expires, not the access token.
They both do. So the authorization code is really short-lived, so just like a matter of seconds or minutes at the most. The access token, I'm going to get it wrong. The authorization code is very short, only just as long as it takes to do that exchange, and then it's dead for security reasons. The access token lives a lot longer. So sometimes it's 30 minutes, sometimes it's an hour, and it's kind of up to the authorization server. In some cases, especially, it's becoming a more and more common pattern on mobile to have really long-lived access tokens. So you notice that you log into Facebook on your phone when you get a new phone or whatever, it very rarely will ask you to log in again. It might ask you to log in again on the PC, like on the desktop kind of often, but on the phone it actually hardly ever asks you to log in again. Maybe if you get a new phone, that's when you have to do it again. The reason is because Facebook decided, for better or worse, Facebook decided that their access tokens last like 10 years or something like that. It's because they decided that their mobile users were going to be annoyed by having to re-log into Facebook all the time. Now, that doesn't necessarily mean that access tokens that Facebook gives to other people, so like the access token that Tinder got from Facebook to access your Facebook info, that is probably shorter lived. But the ones that Facebook gives to their own app that they trust is like 10 years long. And they're okay with doing that because on mobile, there's a kind of additional security measure where you can store that access token in like a really protected part of the device, basically like behind Touch ID or whatever it is on Android, in like an encrypted part of the device. So it's very unlikely that someone is going to be able to steal it. Whereas like on the web, it's a little bit more risky, and typically access tokens are a lot shorter.
Interesting. But
Yeah.
this is all depending on the authorization server.
Correct.
Whatever they set up, it will be.
Exactly. So if you are in charge of the authorization server, you get to decide how long it lives, what the policies are, all that stuff, right? If you're the client, you don't really have a say. You just get an access token, and hopefully it's long enough for what you need to do, or else you're just going to need to get a new one. There is another mechanism for getting a new access token, but it's slightly less common. And I'm not really covering it in these slides, but it's something called a refresh token. So sometimes you can, if you ask for a particular scope, you can get not just an access token, but also a refresh token too. And the refresh token is just a special token that isn't used for anything else other than if your access token is dead and expired, you can just use the refresh token to get a new one, like as long as you want, until the refresh token expires, and then you're really dead in the water. But that mechanism is used less for what you're talking about, like staying logged into an app or getting your fresh info. That's used more for like if you have automated tasks that are running when the user's not around. So if you imagine like an app that like logs into your Gmail every night to like create like a digest for you the next day, or if you've ever used like unroll.me to like take all your like not spam but like marketing like sales emails and like put them all in one place for you or whatever, those types of apps where they're like every night log in for you in like an automated way and do something, they would have a problem if you weren't around to reauthorize if they needed a new access token. If the user's sitting right there, it's perfectly fine. You can send them back through the flow, get a new access token. But if the user's not there, you need some other way, and that's what you can use a refresh token for. But that's getting a little off track because that's kind of like a bit of an edge case. What I want to talk about is OpenID Connect. So we've learned a ton of OAuth terminology, a lot of jargon there. And you might be thinking like, all right, so that's great. I just learned this fairly complicated authorization protocol. Now you're going to talk about another protocol. I need to learn all this stuff over again. Well, the good news is that that's not the case. OpenID Connect is actually just OAuth. It's the same exact terminology. It's just OAuth plus a little bit of extra extension on top of it. But first I want to talk about kind of why do we need an extra extension on top of it. Well, let me give you a bit of history. So this whole protocol that we've been talking about, we started by talking about the delegated authorization problem. So the problem of I want to give this place a little bit of access to my data over here. And that's the problem that OAuth was built to solve, and it solves it really well. The problem is that some people saw how well OAuth solved that problem, and they said, hey, that's really close to authentication, not authorization, but logging in. It's almost the same problem, but not exactly. So people like Google and Facebook started using OAuth for authentication, not just authorization. So they're actually two separate things. Authorization deals with giving permission, like you have permission to use this data or something like that. Authentication involves logging in. So logging in and then using your identity, using your profile. So they're very close, but not exactly the same thing. Yeah.
So is one of them more the client and one's more the resource owner?
Not really. It's a little blurry. One involves permission, and one involves logging. That's the easiest way to think about it.
So one is saying, this is me. I'm the one that is using this account.
Yeah.
And the other one is, what can I do with this account?
Oh, so like you're not an administrator.
Correct.
Yeah, okay.
Your role is member, not admin or whatever. So if you think about, so the kind of examples that we're using here of like Yelp getting my profile and contact list or whatever, the scope of, no pun intended, the scope of that problem is actually pretty small. It actually doesn't, in this example, the client doesn't actually care who I am. They just want to get my data. They want to get access to something. And they want me to give them permission to do that. That's actually a very slightly different enough thing from me logging in and saying like, I'm Nate and this is my email address or whatever, this is my login information. It's different enough from that OAuth is not a super great fit for that login or authentication scenario. But it's close enough that some big players like Google and Facebook started using OAuth for login. So a couple years ago, Facebook introduced like the login with Facebook button that is now everywhere on the web. Google did the same thing with the login with Google button. Twitter has a login button. LinkedIn has a login button. And the idea there is that you don't have to create a password on every single website, right? You can just, if you want to use your Google account or your Facebook account to log into a website or app, you don't have to create a new password. You just use your existing Facebook account. That's cool, except they used OAuth to get that done. And it's a bit of a hack. It's a bit of a stretch of the OAuth protocol, and it's not really what it's meant for. Specifically, the problems with using OAuth for that scenario are that kind of what I was talking about before, every implementation is just a little bit different because the spec is like kind of fuzzy in some key areas, which means that if you're trying to kind of build like a universal login protocol, OAuth is like just a little bit too fuzzy to make it easy. There's also no common set of scopes. So every authorization server has a different way they do scopes. All of Google scopes are like actually full long URIs, whereas Facebook scopes just look like public_profile, user_birthday. It's just a totally different style. So if you're trying to make both of them work in your application for login, you'd have to go to Google's docs and read all their documentation to understand what all their scopes are. And you'd have to go to Facebook's docs to understand how all their stuff works. And that's just a lot of work. Most importantly, for the kind of login and authentication scenario, there's no standard way in OAuth to get the user's information. And if you think about it, that's actually like extremely important for login. If I log into a website or any application, the first thing that application is going to want to know is like who just logged in, what's their name, what's their email address, like who is it, what's your identity. Since OAuth is not an authentication protocol, it's an authorization protocol, it doesn't have any way or mechanism for letting the client know who is accessing or who's the resource owner is. It just says like, yep, they gave you permission, done. So there's no way to get the user's identity, and that's like what you would need in an authentication scenario. What Google and Facebook did when they kind of hacked on top of the OAuth protocol to make this work for the Facebook login button was they added like a non-standard, their own implementation of some type of route or some type of endpoint you can call with an access token to get the user's information. But the way Facebook did it is different than how Google did it, which is different than how LinkedIn did it. So you're starting to get the idea, I guess. So some smart people got together and said like, okay, OAuth 2.0 is great for authorization. It's like 90% of the way there for authentication too, but it's got these little hiccups that make it hard. So out of that kind of work came a new protocol, or rather really just an extension on top of OAuth 2.0 called OpenID Connect. And OpenID Connect is specifically for authentication. So if you already know how OAuth works, like you do now because we looked at it, you already know how OpenID Connect works. It's the exact same terminology, it's the exact same mechanism. And then there's like 10% extra stuff on top of it that make it really nice for authentication. Specifically, some of the problems that I mentioned before, like now there's a standard set of scopes, there's a standardized implementation, the spec is a lot more like strict and explicit about how it should be implemented. So if you have an OpenID Connect compatible authorization server, it just works. And then specifically for the authentication scenario, there's this idea of an ID token. So in OpenID Connect, when you finish the flow, you go through the whole dance, you get back an access token, just like normal OAuth 2.0. But you also get something called an ID token. And the ID token has exactly what you might think is inside of it. It has information about the identity of the user. So user's name, who just logged in, when they logged in, all that good stuff. Exactly what you want for authentication. And then if that ID token for some reason doesn't have enough information about the user, you want more, you can just call this endpoint that all OpenID Connect servers or authorization servers have called /userinfo, and you get more information about the user. So
is that just a GET request?
Yeah,
so
just a
can
GET.
anyone do that?
You need to have an access token.
Oh,
So you go through the whole flow.
User can't.
Correct.
Only the client. Okay.
Correct. You go through the flow, you get an access and ID token, and the ID token you can just immediately consume to understand who the user is, and then if you want to, you can use the access token to go call the user info endpoint. Yeah. So exact same mechanism, but you get this extra little bit that's helpful.
Yeah.
So this flow you're very familiar with now. This is an OpenID Connect flow, which is really just an OAuth 2.0 flow, but there's one new scope there called OpenID. And as long as there's a scope on there called OpenID, it's now magically an OpenID Connect flow. If this authorization server supports OpenID Connect, then specifying that OpenID scope means at the end I'm going to get an ID token. So everything else is exactly the same. I get an authorization code back. I have to exchange that on the back channel, assuming this is the authorization code flow. And then what I get back is an ID token and an access token. And that ID token can be immediately consumed, like I said, by the application to understand who the user is. The ID token looks something like, let's see, the ID token looks something like this. It is a format, kind of a standard format called a JSON Web Token or a JWT. And that is something that looks like this. A JWT actually looks like this, but that is what it looks like when it's encoded. If you decode it, it looks like this. A JWT or a JOT is a kind of standardized format for exchanging like a compact amount of information over the web. It's an encoded format, which means it kind of looks like gibberish if you just see it in the browser. It doesn't mean that it's not encrypted in the sense that it's like encrypted with a password or anything. It can just be decoded. It's just like a base 64 encoder. It can be decoded by the client or the browser, and you get something like this. It's a JSON document that has a few properties in it called claims. Yeah.
You say encoded, kind of like when you open up a Word document, like in Notepad. Right?
Kind of, except more like, so the real version of it looks like, the unencoded version of it looks like this. It's a JSON document with like braces and brackets and all that stuff. The point of encoding is actually to make it like URL safe. So some of these characters are not legal in a URL, right? Or they represent stuff in the URL. Like there might be a slash in here somewhere, and that would mess up a URL. Exactly. So the idea here is that you take all this stuff, you have like this little header thing, you have these properties called claims, and then a cryptographic signature. You mash all that together, you send it through just base 64 encoding, which produces alphanumeric characters like this, and it's guaranteed to only be like A through Z, 0 through 9, and no other special stuff. And I guess dashes too. You can see the different pieces here, the header, the body, and the signature, and they're actually separated by periods. And if you look for this pattern, they almost always start with EYJH6 or EYJHB because they always start with an opening bracket, and that's how it gets encoded in base 64. If you look for that pattern, you'll see it on the web actually quite a bit because a lot of websites use these. And you can, if you come across one of those, you can just copy and paste it and put it into a decoder and see exactly what it looks like. I'll show you an example of that. So if you come across a JWT and you can copy it, you can open up a tool like jsonwebtoken.io. Assuming you have Wi-Fi, that's there.
This
There we
isn't
go.
a security thing, it's just a browser.
Exactly.
adaptation.
Exactly. It's not making the value secure because anyone could trivially decode it, but it's making it safe to transmit around in the browser, and it's like a standard. It's a standard format that basically like every device and every language has some package for decoding, so it's like really easy to consume. I'll paste in a JWT I have here, and then you can see like that's what the header looks like, that's what the payload looks like. It's got some stuff, some claims about the user, so what authorization server issued it, what the user's name was, usually their email address, some other information about them, when the token expires, all that good stuff.
Are these standard or is it based on whoever implements it?
A little bit of both. So the spec says it has to have at least these claims, like a standard set of claims, and then the authorization server, if they want, they could pack more claims in there. Yeah. So some of these here are standard. Some of them are weird stuff that the authorization server I'm using added. But the standard ones are like subject or sub, ISS or issuer, EXP or expiration, all that good stuff. So the other, oh dang. Keep forgetting that doesn't start where I'm currently, there we go. So the other cool thing about a JSON Web Token is that it has this signature. And what I was showing you before when I decoded it was just the header and the payload. The signature, it doesn't decode to anything readable by humans because it's like a hash, a cryptographic hash that's stamped onto the token. But what that allows the client to do is pretty cool. So when the authorization server kind of creates this token or mints this token, it stamps in a signature that says, I'm the authorization server that created it, and here's my proof. And also, here's the current contents of the JWT. Then the client, without having to go talk to the authorization server, can look at that signature, the bytes in that signature, and then recompute and check whether A, the authorization server actually did issue it, and it wasn't like some other malicious guy who said, oh yeah, this is definitely a valid ID token. And also, it can check whether the contents have been modified. So I couldn't go in and change some of those characters and then call that the ID token because the signature would no longer match what was stamped originally by the authorization server. So that's pretty cool. It's like a totally, asymmetric way of being able to verify that this hasn't been tampered with. Because I don't actually have to go talk to the authorization server. I can compute this myself.
Is that similar to how blockchain works?
Ooh. In a distant way, yes, because they're both using this idea of computing cryptographic hashes. Yeah, totally. I don't remember what hash algorithms blockchain uses. This is using like SHA-256. Actually, that might be the same.
I think that might be it.
Yeah.
No, it's just the idea that once it's modified, it changes. And
Correct. Yeah, so the idea that if you change even a tiny bit of the input, the output is drastically different. So yeah, totally the same idea. So the client can independently verify that this is valid. And then, as I mentioned before, if the client wants more information about the user beyond what's in the ID token, they can go talk to the user info endpoint with the access token they got, and that usually dumps out even more information about the user. So a question I get a lot is, okay, cool. OAuth is cool, OpenID Connect is cool, but if OpenID Connect is the newer one, does that mean like I use that instead of OAuth 2? Is it like kill OAuth 2 or something? And the answer to that is no. Actually, these are separate protocols for different use cases. So it's not a question of like, should I use one instead of the other? It just depends on what you're trying to do. So if you're trying to do authorization, ask for permission, grant permission, that kind of stuff, you're talking about OAuth 2.0. If you're trying to do authentication, logging in a user or letting a user log into your system, that's OpenID Connect. And they typically are both used in an application if you have a complex enough application. Cool, that's about it. So I have a little bit more information about like what grant type you should use and how tokens are validated and stuff, but I'll open it up to any questions that y'all have. You first.
With your timeline, it sounded like when Facebook and Google and all them started using OAuth for authentication, that was before OpenID Connect was really a thing?
It was, correct.
So have most of those big players now adopted OpenID Connect? Or are they still using the kind of bastardized OAuth version?
Yeah. Google has. Google switched over to OpenID Connect recently. Facebook, to my knowledge, I haven't checked like really recently, but Facebook hasn't.
Okay.
And then I think like Microsoft has, and I don't think LinkedIn has.
So when you were like, if it's this, you're using OAuth, and if it's this, you're using OpenID, that's somewhat dependent on when the client started using
That's
when the authorization
right.
started using it.
Right. I guess that's what you might call like a forward-looking statement. That's what you should be using. If you're still connecting to Facebook, I think they haven't changed their implementation. Google has. Google was actually part of the OpenID Connect draft spec process, if I remember right. So they were like heavily on board with it and in the beginning and helped shape it and stuff like that. So Google's super on board. I don't know what's going to happen with Facebook. Yeah.
I'm getting confused, but the OpenAuth was authorization,
Right.
and OpenID Connect is OAuth plus extra,
Correct.
but it's authentication.
Correct.
Why can't you use OpenID for both? If it does both, if it does the original and more, why can't
Right.
you do both?
That's actually a really good question, and the answer is like you could do that. So actually, it's really fuzzy because people kind of talk about OAuth and OpenID Connect as separate things, but they're really more like stacked on top of each other. So if you're using OpenID Connect, you're already using OAuth. So it's not like a question of using them separately, I guess. So like, yeah, if you need to do authorization, you're already using OAuth. And if you need to do authentication, you should use OpenID Connect.
So it's not like, oh, I got my OpenID sorted, now I need to do OAuth.
Exactly.
You're just saying like almost pedantically. Like,
Right.
Okay.
Right.
I see what you're
And it's more the other way around. It's more like you might have your OAuth sorted, but if you want to do login, you really should be using OpenID Connect. Right. And honestly, all that means is really basically one thing. You're adding that OpenID claim or scope to your request, and then you're like understanding that you're getting an ID token. Yeah, that's basically it. So it's referred to or talked about as if it's separate protocols, but it's really just an extension on top of the other one. Yeah. It's more confusing than it should be, but this is the world we live in. Any other questions? Those are good ones.
Actually, when you use OpenID to say authenticate yourself for another service, do they then have to provide you with the permissions for the authorization things, or if you sign into a website with your Google account, are you just granting them whatever they want?
That's a good question. It may actually somewhat depend on the implementation. I think, I don't think, it's not super common to ask for consent when someone's just logging in. Or you may ask for like, are you sure you want to allow them to have like your public info, your public profile or whatever?
I thought that was just that Facebook specific thing.
It might be actually. I haven't looked at like all the different authorization servers and how they do it. Some of that may still be up to a little bit of an interpretation or a little bit of implementation. Yeah.
Just what the authorization server has something built into their button that says login with Google. They know what access code goes with the ID, what access token is supposed to go with that ID token.
In other words, can you restate the question?
Like if Google lets you embed the signing with Google button on your website or whatever, they know what they've decided ahead of time what information they're going to release for the users that use that.
Oh, yeah, pretty much, yeah. Yeah, they usually give it like pre-configured for you. Yeah, totally. So it's usually not requesting a ton of stuff, probably like just the profile, just the public info or whatever. And then of course you can like customize it really. If you understand how it works, you can customize it to request whatever you want. But the login with Google button is typically just, I think, I'd have to double check, but I think it's just requesting OpenID and profile as the scopes.
So is there a way I, as the resource owner, can figure out what is being allowed when I log in with Google?
Sure, yeah. If it's not explicitly asking you for consent, then it's going to be, actually no. To answer your question specifically, I had to think about it for a sec. It actually always will ask you for consent, even if it's just the basic info. And the reason for that is because the first time you connect any client to an authorization server, it's going to ask you about it. Only the first time though. So if you've done it before, it's not going to bother asking you again. If it is the first time though, even with Google, with the default Google button, it'll ask you like, are you sure you want to allow like the New York Times to connect to your Google account or whatever? Yeah.
Gotcha. How does it keep track of the first time? Is that stored in the browser, like a cookie?
No, that's actually stored, it's on the authorization server. So the authorization server keeps track of that.
It sends requests like, has this happened yet?
Yep.
Okay.
If a user uses OpenID and then later wants to revoke those permissions, would you have to design a way to allow users to do that, or
Yes, you would, yeah.
would they just have to delete their account?
Hopefully it's better than them just having to delete their account. There is a concept of the user later revoking consent. Descoping, right. So you can actually see this in some implementations. So if you use GitHub, for example, GitHub has GitHub applications, which is just OAuth, and you can agree to let certain plugins have certain access, but you can always go in later and revoke them. Actually, you can do the same thing with Google. You can go.
You can do the same thing with Microsoft as well.
Yep. Pretty much. What's that?
Facebook.
Okay, yeah. I haven't looked at Facebook in a while, but I know for GitHub and Google, you can always go in and be like, nope, I don't want them to have access to me anymore.
Right.
Um,
There's always like a huge, like, big permissions list.
right.
on the site.
Like, did I really give that many applications permission to my stuff?
Depending on how long you've been using it.
Yeah. So the interesting thing is what happens when you do that. So when you revoke consent, you say like, I don't want them to have access to that anymore. That client application is not necessarily notified. Their access tokens just probably stop working at some point.
So they knock on the door and you're like not part
Nope.
of the club anymore.
Unauthorized, yeah. Yeah. And it's up to the client application to maybe handle that gracefully or not, I don't know. I did that recently actually because I was using the service unroll.me for a while,
Yeah,
which
me
like,
too.
yeah, pulls all your junk email out and kind of like sorts it for you. And then I read all the story about how like they were selling your private info or something like that, and I was like, F that. So I went in and revoked consent on them, and then I started getting a bunch of emails from their service like, we can't connect anymore, something must have broke, did you forget to authorize us and stuff? I'm like, no, I did that on purpose. Yeah. So that's you didn't know it, but you went through an OAuth deconsent process there. Yeah. Yeah. It's pretty interesting stuff, especially how basically the whole internet kind of decided that this is the protocol or the standard that they'll do stuff with. And then from that, like it was a couple like 2012, I think, that the OAuth standard was kind of ratified. And now pretty much everybody uses it, and people have been kind of slowly building on top of it. The core spec describes these flows that we've been talking about, but it doesn't necessarily mention anything about like the deconsent stuff we're talking about or how to handle those things. So there's like this whole series of extensions that have been added to the OAuth spec over time. There's like quite a few of them now, like probably over a dozen, that all deal with some small part of it, like how is this handled on mobile? How is it handled when somebody does deconsent? What if the user has multiple accounts? Can they pick which account they're using? Like all this stuff is being kind of slowly added, which is kind of interesting. And then OpenID Connect is in that bucket as well of things that were added on. Let me just skip through some of my other stuff because this is mostly review and just get to my end slide. So I'm happy to answer any other questions you have. If not, got a couple of resources for you. If you want to learn more about like OAuth, you can always like read the spec itself, but it's pretty difficult reading. If you go to OAuth.com, my company sponsored like a free ebook that lets you read kind of about the spec, understand more about this stuff. I don't have any more like physical copies with me, unfortunately. All the people at the meetup last night stole them all. But if you go to OAuth.com, it's just a free ebook that you can read and I think download a copy. Also, if you want to play around with this stuff, my company basically runs a hosted authorization server. So if you go to developer.okta.com and sign up, you basically get an authorization server of your own that you can play around with. And it's pretty cool, actually. You can create users, create applications, and then connect client applications to your authorization server and kind of do all this stuff, except you don't have to do run all the complex stuff about like managing your own authorization server. We just handle it for you. So that's it. That's all I got. Let me know if you have any questions.
I have a really quick question. This is more of a curveball.
No time for questions.
It's not related to this presentation, but more of a, how do you have a process to problem solving?
Ooh, I'm gonna have to sit down and think
So
about
like
it.
debugging OAuth, is that the idea?
Do I have a process for problem solving? Like when I'm working
So
on this stuff?
when you encounter a problem at your hands, your thought process or what do you do or what do you think to tackle this issue? So
Well-
let's say OAuth was not a thing and you needed to implement that.
Yeah.
Like, what are the first things you normally look at when you have issues with it?
Stack Overflow?
I mean, what are the most common problems people have with it?
With this specifically? The most common, like if you're implementing it, if you're trying to set it up, the most common problems you'll have is that, I mentioned it a couple of times how every implementation of OAuth is just a little bit different because Google did a little bit different than Facebook did, et cetera. And that can be tricky because when you're trying to connect and like get all those URLs correct and get the redirect correct and all that stuff, it's really easy to mess something up. So what you'll end up doing is like get everything set up, you think it's working, and you click the button and you get an error. And sometimes it's a very unhelpful error. It's just like 400 bad requests. And That's actually one reason why I created that debugger tool, because if you're like building an app and you're trying to get this working against Google, for example, if you get like something wrong, you like forget the client ID or you use the wrong one or you put the wrong scope in there or something like that, generally you're just going to get like a super generic error message. Or you're going to get an error message coming back in like a query string, but it's going to be like all garbled unless your app understands how to like decode it. So I built that debugger tool so that you can kind of like, before you connect your app to it, you can connect the debugger to it and just make sure that the whole flow is working correctly. And then once you know it's working there, you can plug your app in. It's a little bit easier because then if you get error messages back, the debugger will like decode them for you and show them to you instead of you like having to like try to like look through the characters of some like obscure message that came back or something. So that's kind of helpful. To answer like general problem solving approach, I would say that it's tricky. I usually try to obviously try to like understand as much about the problem as I can, but that's not always feasible because sometimes like the rabbit hole on some of this stuff goes like very deep.
Yeah.
I usually try to like, if I can get to something that's working, even if it's like ugly and doesn't look pretty and it's like really scrappy, if I can get to something that's working, then I at least have like an anchor that I can go clean up my code and refactor it and stuff and know that like I had it working and I can always go back, if that makes sense. Because then if you have
the variables, right?
Right, like so, exactly. Remove as many variables as possible. If I know I have it working, then I can go try to change stuff and then I'll know what is breaking, right?
So would you be casting like a wide net to try to figure out what little piece you can fix, or try to figure out what's the most important piece that you want to work on and then tackle that one until it works?
Probably the latter. Yeah. Probably hammer something until I get it working. And then I can solve the other problems. Yeah.
Okay, awesome.
Does OAuth work with HTTP, or do you have to have HTTPS?
Technically, there's nothing stopping you from using it over
Because
HTTP.
the important secure stuff is happening on the back end, right? Back channel.
Yeah. It's like nothing's going to stop you from using it over HTTP, but you shouldn't. The spec says do not use this over HTTP. But like if you want to ignore that, you can do it. It's just not a good idea. The specific bad stuff that could happen if you use it over HTTP is, of course, someone can steal the authorization code and then probably couldn't do anything with it, but it's not great. If you're using the implicit flow, they stole your access token, and that's really bad. Because the access token, once you get an access token, that's like the keys to the kingdom. If I have your access token, I'm essentially you. I can do whatever you can do. So that's really bad. HTTPS is like, I don't know, it's like super important. Yeah. There was something else I was going to say about that, and now I forgot.
Do you use like Let's Encrypt?
Yeah, Let's Encrypt is actually really awesome. It used to be, people used to argue against using HTTPS and against using encryption because it was really expensive. You had to pay like $500 to VeriSign to buy a cert, and it was like pretty hard to set up and just like clunky. That's all, and it's slow. It's like slows the browser down and all this stuff. And that's all pretty much like, those objections are now pretty much nonsense. Like, you can do it with Let's Encrypt for free. It's pretty easy to do. It doesn't slow browsers down anymore. Like, there's, other than like a little bit of a learning curve the first time you have to set it up, it's like relatively easy now to get HTTPS working, and it's like, I think even more important than it ever was before, really, because not only is there the security concern where like, you just don't want people watching your data go across the wire, but there's also now like the privacy concern. So like Europe is really crazy about privacy now with GDPR, and people are really sensitive to the fact that like the NSA is trying to watch everything that's said over any network. So just having that guarantee that the connection is encrypted is really important. Yeah. I'm a big fan of HTTPS.
Yeah. There's a web server called Caddy that practically automatically sets it up for you.
Wow.
It's pretty
haven't played with Caddy, but I have played with, if you have you ever done anything with AWS, like the Amazon ecosystem?
I have.
So there's a bit of a learning curve there. AWS can be quite overwhelming when you first set it up or get involved. I swear, like, you log in and it's like, which of these 40 services do you want to use? You're like, I don't know what any of those are. I still only know like 5% of what to do in AWS, but one really cool thing that you can do is they'll actually provision certificates automatically for you. So like Let's Encrypt, except even less work that you have to do. So like if you're using Cloudflare, which is their CDN, and you have something behind Cloudflare, like your own site or your app or whatever, if you have Cloudflare distributing your stuff, you can actually use what's called Amazon Certificate Manager and say like, I want to make this Cloudflare endpoint HTTPS, and it'll go get a cert for you, automatically get it, and automatically renew it as long as you want. Totally free. It's super awesome. So like I have my own personal blog is just like a static site that I'm hosting on Amazon S3, and it's hosted behind a Cloudflare CDN. CloudFront, I'm saying the wrong one. Flare is the other company.
Oh, yeah, okay.
CloudFront.
Did
CloudFront.
Amazon acquire it?
No, Cloudflare is the one that spilled everyone's SSL info onto the internet. CloudFront is the Amazon thing, sorry. I have my site posted on S3 behind CloudFront, and then if you go to my site, it's all HTTPS because it's behind CloudFront. It's super cool. And I didn't have to pay for it or even spend any time setting it up.
Well, that's nice.
Yeah.
This is a bit of a digression. Sometimes if you type in Facebook, it automatically redirects to HTTPS.
Yeah.
Even if you don't type in HTTPS.
Yeah.
But some sites, if you type HTTPS, it works. But if you don't, it also works. It doesn't redirect.
Yep. Yep.
Is that on purpose, or is that like they didn't add a redirect thing on the
It's
domain side of things?
It's either on purpose or they're being lazy.
Okay.
So they might be being lazy and just didn't add a redirect.
Okay.
Most of the time it's on purpose for one of a few reasons. Either like they think that there's some users that like can't get HTTPS for some reason, like maybe some people using a super old browser. It's really not a legitimate concern anymore, but like sometimes sites want to have a non-HTTPS version because they think it's important for some reason. Or they didn't design their site very well, and all of their, like, if you have hard links everywhere on your site that all point to HTTP, that's going to be a problem. If you try to redirect everything to HTTPS, all your links are going to still be trying to go to HTTP, which if they're links that people are clicking on, maybe they'll automatically get redirected too. But things like image tags or script tags are going to be pointing to the wrong thing, and that's actually going to most browsers will fail to load that.
Yeah.
Because it's like, no, you can't load an HTTP asset over an HTTPS site. For security reasons, they'll be like, no. So the site breaks. And so then people are lazy and just be like, no, I don't want to do it.
Yeah, no, Google will be like, go back to safety.
Yep.
You seen that? Is that going to, do you think that's going to eventually be like, they just won't even let you? Because the way it currently is, you can like say advanced and then say, yeah, I know, I'm
Yeah, they do talk about that. They're trying to get everybody to kind of.
Google's actually being really aggressive about it, which I like.
Yeah, they're doing the little icon.
Yeah.
And,
they're
Yeah,
not
so-
secure. If you ever
Yep.
type in an input, it's like not
Yep.
secure.
I don't think, they're probably not going to change that thing where you can bypass it, like you click like, I know what I'm doing, advanced, and get through. They probably won't change that because occasionally, if you're doing like development, you'll get yourself in a situation where you actually do want to bypass it because you're testing something or whatever. The thing that they are going to do is add that icon. So they already added it in like Chrome 61 or whatever. They added it so that if you are typing info into a form, but it's only HTTP, it'll like put a big red X in there and be like, this is not secure. What they're in the next version of Chrome, they're going to extend that and be like even more aggressive about it. Anytime you land on any site that's only HTTP, they're going to basically tell you like this site is not secure, and have a big red X in the corner, which I think is great. Because it's going to make a bunch of sites that are being lazy about moving to HTTPS, it's going to make them seem like really dangerous, which is like kind of true and kind of a stretch, but yeah, Chrome is being really aggressive about pushing people to HTTPS.
My static site is going to hack you.
Yeah, not really. But there's actually some stuff you mentioned, like some sites, if you try to type HTTP, it won't even let you, like just pushes you to HTTPS. There's actually, in most browsers support something called the strict transport security header now. So the site can actually send a header down to the browser in the responses from the site that tells the browser, hey, I'm HTTPS, obviously, but also don't let anyone ever connect over HTTP. So even the browser even will enforce it, not just the site. The browser will not let someone connect over HTTP, which is pretty nice.
That's cool.
You can, it's like 5% possible to shoot yourself in the foot, because if you don't have your HTTPS cert set up correctly, and you turn that on, nobody can ever access your site. But as long as you don't have that problem, if you test it first, then it's awesome. I want to make sure that I don't take too much of your time. If you have any questions, feel free to email me or tweet me or anything. I'll put up the slides to this talk on my Twitter right after, so you can check it out if you're interested. And thanks so much for the opportunity to speak. I had a great time.